Consider the differential equation dy dx is 4 minus y over 10, where y equals 2 when x equals 0. Use Euler's method with a step size of 0.1 to find an approximation for y when x equals 0.5. Give your answer correct to 4 significant figures. So Euler's method makes use of the small difference. Delta y is dy dx delta x. So for the first step, what we're going to have is dy dx evaluated at our start point. So that is at 0, 2, and multiplied by 0.1, which is the delta x, because that's the step length. So if we've got y equals 2, put it in there. 4 take away 2 is 2, divided by 10 is 0.2. 0.2 times 0.1 gives us 0.02, and then add that to the current y, which is 2.02. So that's taken us to the point 0.1, 2.02. The x has gone up by 0.1, the y went up by 0.02. Then the second step is delta y is dy dx, but this time evaluated at 0.1, 2.02, multiplied by 0.1. And so that ends up being put 2.02 into our differential equation, 4 minus y over 10, and we get 0.198 times 0.1, and so that is 0.0198. Add that on, gives us, onto the previous value of y, gives us 2.0398. So we're now at the point 0.2, 2.0398. And we're going to just repeat those steps. And the next value of y that we should get is 2.059402. The one after that is 2.07880798. And then finally we get 2.098019, a value we're going to use in part C of the question. By solving the differential equation, show that y equals 4 take away 2e to the negative x on 10. So this is a separable equation. We can write that as the integral of 10 over 4 minus y dy, and that will be equal to the integral of 1 dx. So that gives me negative 10. That's because of the reverse chain. When we differentiate 4 minus y, we get negative 1. Ln mod 4 minus y is equal to x plus a constant. Therefore, ln mod 4 minus y would be equal to negative 1/10 x plus a constant. And so 4 minus y is e to the negative 1/10 x plus a constant. And of course, that can be split into e to the negative 1/10 x times e to the constant. And so 4 minus y is ae to the negative 1/10 x. And then we can use that y is 2, x is equal to 0, giving us 2 is equal to a. So 4 minus y is 2e to the negative 1/10 x. And we can rearrange that to 4 minus 2e to the negative 1/10 x as required. Okay, so part C wants us to find the absolute value of the error in the approximation to part A. So What we're after is, first of all, y of 0.5. So just substitute that into here. So that's 4 take away 2e to the negative 1/10 times 0.5. Calculating that gives us 2.0975 41151. And so the absolute error is 2.0980199. Take away 2.0975411151. This value having come from earlier in the question in part A. And if we do that, we get 0.000478 and so on. That 8 rounds, if you're going to round to 3 significant figures, we'll give it as 4.79 times 10 to the negative 4.